Why isn't the ocean flat if it covers most of Earth? The answer is surprising and a little scary. Gravity isn't the same everywhere, and it's quietly reshaping our oceans right now. That shift could affect sea levels, currents, and even our future. Let's break down what's really happening. Earth looks simple from space, a blue planet covered in water. And about 71% of its surface is one giant connected ocean. So you might expect all that water to sit at the same level everywhere, but it doesn't. In fact, the ocean's surface is uneven in ways that sound almost impossible. Some areas are higher, some are lower, and in one place the ocean dips so much it forms a giant gravity hole. So what's going on? Let's start with something surprising. At the Panama Canal, the Pacific Ocean actually sits higher than the Atlantic Ocean. Not by waves or tides, but by a steady difference of about 8 inches. That may not sound like much, but across an entire ocean, it's huge. Why does this happen? First, temperature plays a role. Warm water expands. The Pacific Ocean is usually warmer than the Atlantic, so its water spreads out more and takes up extra space. That makes it slightly higher. Second, salinity matters. Saltier water is heavier and denser, so it sinks a bit lower. The Pacific, in many areas, has fresher water than the Atlantic. That makes it lighter, so it sits higher. Then come winds and currents. Strong trade winds push water across the Pacific from east to west. Over time, this water piles up along coastlines, especially near Asia and Australia. But here's the most important part, and the most surprising. Gravity itself isn't the same everywhere on Earth. We usually think of gravity as constant, but in reality, it changes slightly from place to place. Mountains, continents, and even hidden structures deep under the ocean all pull on water differently. The ocean doesn't follow a perfect shape. It follows gravity. Because of this, global sea level can vary by as much as 10 feet between different regions. That's right, there's no single sea level. It depends on where you are. Now imagine trying to build something like the Panama Canal in the middle of all this. At first, engineers thought they could simply dig a straight path and connect the two oceans at sea level. Sounds simple, right? It wasn't. The land in Panama is steep, muddy, and unstable. Every time workers dug into the ground, it collapsed back in. During heavy rains, entire sections flooded and buried equipment. And things got even worse. Workers started getting sick. At the time, people didn't fully understand that mosquitoes were spreading deadly diseases like malaria and yellow fever. Thousands of workers lost their lives. The original project failed completely. Years later, engineers tried again, but this time they worked with nature instead of fighting it. Instead of digging a flat canal, they built a system of giant water elevators called locks. Here's how it works. Ships enter a massive chamber. The gates close. Then water fills the chamber, lifting the ship about 85 feet into the air, roughly the height of an 8-story building. The ship then travels across a large artificial lake in the middle of Panama. After that, it gets lowered back down on the other side. It's like moving ships over a hill using giant water-filled boxes. And this solution worked because it respected the reality of Earth's uneven surface and its uneven gravity. Now let's go deeper. To really understand this, we need to stop thinking of Earth as a perfect ball. Instead, imagine it as a lumpy, spinning potato. The middle bulges slightly because of rotation. The crust isn't uniform either. Some areas are thick and dense. Others are lighter and thinner. All of this affects gravity. Scientists use a special concept to describe the true shape of Earth's water surface. It's called the geoid. The geoid is what the ocean would look like if there were no waves, no winds, and no tides, only gravity and Earth's rotation shaping it. And guess what? That shape is full of bumps, dips, and uneven areas. Over dense regions, gravity pulls harder, so water piles up. Over lighter regions, gravity is weaker. So water sinks lower. One of the strangest examples of this is found in the Indian Ocean. There's a massive area where gravity is weaker than normal. Because of that, the ocean's surface there dips dramatically, more than 328 feet lower than surrounding areas. That's like a 30-story building carved into the ocean's surface. This feature is known as the Indian Ocean Geoid Low. It covers around 1.2 million square miles, making it one of the largest gravity-related features on Earth. Scientists first noticed it back in 1948 during a survey at sea. Since then, it has remained one of the biggest mysteries in Earth science. Why would gravity be weaker in such a huge area? For a long time, no one knew. But now scientists think they're getting closer to an answer. Deep beneath this part of the ocean, something strange is happening. Huge plumes of hot material, almost like slow-moving lava blobs, are rising from deep inside Earth's mantle. These plumes push upward, changing how mass is distributed inside the planet. And when mass shifts, gravity shifts too. If there's less dense material underneath an area, gravity becomes slightly weaker there. As a result, ocean water sinks lower in that region. To test this idea, scientists ran detailed computer simulations. They rewound Earth's history by about 140 million years to see how this region evolved over time. What they found was fascinating. Long ago, an ancient ocean existed where the Indian Ocean is today. Over millions of years, tectonic plates moved, collided, and sank deep into the mantle. These sinking slabs likely disturbed the material below, triggering the rise of hot plumes. So the gravity hole we see today may be the result of events that happened millions of years ago. It's not a hole in the water. It's a dent in Earth's gravity field, and it shows just how connected everything is, from deep inside the planet all the way to the ocean surface. But this isn't just a cool science fact. It has real effects. This massive dip influences ocean currents, sea level measurements, and even satellite paths. It can affect how we track climate change and rising seas. And that brings us to an important question. Will this gravity dip ever go away? The answer is, we don't know for sure. Earth's mantle is constantly moving, but very slowly. Hot material rises, cold material sinks, and over millions of years, these movements reshape the planet. It's kind of like a giant lava lamp beneath the surface. Over time, these shifts could smooth out the gravity differences, or they might keep them going for millions of years more. Scientists are still working on better models to understand this, but it's not easy. We don't have a perfect record of what Earth looked like millions of years ago. Continents were in different places, oceans opened and closed, huge volcanic eruptions changed the surface. Even today's best models only match about 80% of what we observe. There are still gaps. For example, one major volcanic event, the formation of the Deccan Traps in India, may not be fully included in some simulations. That eruption covered huge areas with lava and likely changed the mass inside Earth. Missing details like this can affect how accurate the models are. But even with these uncertainties, one thing is clear. Earth is not stable in the way we often imagine. Its surface, its oceans, and even its gravity are always changing. And these changes can have real consequences. As gravity shifts, it can influence where water gathers, how currents move, and how sea levels rise or fall in different regions. That matters for coastal cities, weather patterns, and ecosystems. So while we often think of the ocean as calm and steady, the truth is very different. It's constantly adjusting to forces we can't even see. And right now, gravity is one of the biggest forces shaping it. Earth isn't as simple as it looks, and neither are its oceans. If gravity can reshape the sea itself, imagine what else is changing beneath our feet. If you found this interesting, make sure to like the video and subscribe to our channel for more amazing science stories that reveal how our planet really works.